Finally, let's consider how we can use two stacks in order to implement a queue. So in queue is the same as pushback, and DQ is the same as pop front. So I just want to put that. So in queue is pushback, and DQ is pop front. And different authors will use different terms, so I just want to mention that those are the same thing. So if I want to in queue, so you'll notice I'm using two stacks which is last in first out, but I want to have these two stacks behave together as though it is the first in first out protocol. So in order to in queue, I'm just going to push on stack 1, but you'll notice that I would want the items removed in the order in which they arrived for a queue, but that's not the case for stack. Stack is last in first out, and queue is first in first out. So in order to DQ, I have to be a little bit more clever, and we have to do a little bit more work. So in order to DQ, if the stack 2 is empty, if the second stack is empty, we're going to pop everything from stack 1 and push it onto stack 2, and then we're always going to pop from stack 2. So how can we think about this? We're going to think about our stack 1 represents the back of the queue, and stack 2 represents the front. So the top of stack 1 represents the back of the queue, and this top of stack 2 represents the front of the queue. So let's see how this works. So we're going to in queue say the numbers 3, 4, and 5 in that order. So when I in queue 3, it's going to be at the bottom of the stack, and then I in queue 4, and I'm going to put it on top of it, and then in queue 5. So notice we have them in reverse order in stack 1 when we push them onto the stack. Now the problem becomes DQ. When we DQ, we want the first item in the list. So this first item is actually 3, it's not 5. So 5's at the top of the stack, and that's not the one that should be at the front of our queue. It should be 3. So this is why we have to do something special for DQ. So we see our stack 2 is empty, and this is when we have to pop everything from the first stack and push it onto the second stack. So here's what we're going to do. So now we have to pop everything from stack 1 and push it onto stack 2, and I'll draw this arrow a bit larger so you can see. So I'm gonna pop and push right here. And if we were coding this carefully, we would first have to get the value using top, then pop it, and then push. So here the end result though is that we have 5. We just got 5, removed it from stack 1 and pushed it onto stack 2. We would get the value 4, which would now be at the top of the stack, pop it, and then push it onto stack 2. And then finally 3 would be at the top of the stack again. We'd remove it and we'd push it onto stack 2. Now if we actually have completed that, so we can see that stack 2 is not empty, now in order to get the value to DQ, now we have to do a top if we want to see it, but we can then just pop it, and that would remove the front. So when we pop, we will have removed 3 from the front of our queue. And you'll see that now if we wanted to dequeue, again, to get 4 out, we just have to pop from stack 2. So as long as stack 2 is not empty, we can just call pop on it. Otherwise, we have to transfer everything from stack 1 to stack 2, and then we can do our pop. But as you can see, we can implement a queue using 2 stacks. And you might want to consider how expensive this is. So when we get to runtime analysis, we'll talk a little bit more about this. But how expensive is it to use 2 stacks to implement a queue in terms of the time efficiency? So that's something that we can definitely think about. But the key takeaway is that we can implement a stack using 2 queues by having the first stack, stack 1, the top of it represent the back of the queue, and the top of the second stack, stack 2, represent the front of the queue. And then we can just implement this queue operations by putting wrappers around the stack operations. A very nice practice exercise may be to use STL stack in order to implement this queue using 2 stacks. So you'd need only instantiate 2 STL stacks events, and then you can implement exactly as we had sketched in this diagram in terms of in queue and dequeue, or pushing back and popping from.